Hello students, I Dr. Rekha Mittal from Department of Chemistry, JECRC College. Today we'll discuss about the experiment, that is experiment number 3. The objective of experiment number 3 is to determine the amount of dissolved oxygen, that is DO, present in a given water sample. Now apparatus or reagents required: pipette, burette, BOD glass bottle, glass rod, conical flask, standard sodium thiosulfate solution of normality N by 40, sodium azide solution, that is 5%, Ki solution, manganese sulfate solution 4.8%, starch as an indicator, and concentrated H2SO4. Now we should know about the theory of the experiment. The principle involved in the determination of DO is to bring about the oxidation of Ki to iodine with the dissolved oxygen present in the water sample after adding manganese sulfate, KOH and Ki. The basic manganic oxide form act as a oxygen carrier to enable the dissolved oxygen in the molecular form to take part in the reaction. Since this reaction is iodometrically, so the iodine is liberated. The liberated iodine is titrated against a standard hypo solution using starch as an indicator. Now this is the reaction in which when we are using the BOD bottle, in which we are taking the tap water and we are mixing all the chemicals, that is the Ki solution, azide, manganese sulfate, then the white precipitate is formed. So this white precipitate is of basic manganic oxide. Then in the next reaction, the white precipitate is treated with H2SO4, that is we are adding H2SO4 in the BOD bottle. Then that white precipitate get dissolved and we get the yellow brown color solution, and from this solution we are doing the titration and by using starch as a indicator. As we are adding the starch, then blue color appears, and this blue color is because of iodo starch complex, which we are representing that reaction at last, that is starch plus iodine, that is iodo starch complex. Now before starting the experiment, we should know about the steps, what steps we have to follow. That is, we should know about the procedure. Take 300 ml water sample containing DO in it in a BOD bottle. Add 1 ml of manganese sulfate, alkali, iodide, azide solution to the bottle containing water sample. Then brown PPT are formed in the bottle. After 15 to 20 minutes, add 2 ml of concentrated H2SO4 and shake well. Then the precipitate get dissolved and we get the reddish brown color solution appears due to the liberated iodine. Since the titration is iodometric titration, so iodine is liberated in this reaction. Then take 10 ml of above solution in a conical flask and add some sodium thiosulfate solution to it till the solution become light yellow. Add 3 to 4 drops of starch solution as an indicator. A blue color appears, and this blue color is because of iodo starch complex. Then we have to titrate it with the hypo solution. Then the color disappears, blue color disappears. Note the reading. This represents the end point. End point is that point where the reaction just completed. So we note down the reading, repeat the titration till you get the concordant reading. So once you have taken the reading, then you have repeatedly do the experiment till we get the concordant reading, that is we get the same reading in continuation. Now we start our experiment in laboratory.
Now we will start the experiment for calculating dissolved oxygen in the water sample. For this is the BOD bottle. In this we will take the water sample, 300 ml. So we will take 300 ml water, tap water, and then these are the solutions: manganese sulfate, KI solution, azide, starch as an indicator, and NaOH pellets. Now, in this 300 ml water sample, we will take 1 ml of solution. These solutions, 1 ml manganese sulfate, 1 ml KI solution, 1 ml azide, sodium azide, this reaction, this titration is iodometrical titration, which means that iodine is liberated in this titration. Now all these three contents we have added in this BOD bottle. Now we will add NaOH pellets, 4 to 5 pellets, and then the reaction starts. We'll just close this BOD bottle and then shake it well, up and down, so that the proper reaction takes place. Now we'll set the precipitate start forming, and as the precipitate settle down, then we'll do the titration with this hypo solution which we have taken in the urine. So after some time, the precipitate start forming. These are the precipitate, brown precipitates are formed, and after some time, for 15 to 20 minutes, these precipitate will settle down at the bottom. After 15 minutes, these precipitate are formed, which is settled down at the bottom. Now, we'll remove the water from the top. Now, in this precipitate, we'll add 2 ml of H2SO4. 2 ml of H2SO4 is taken in the measuring cylinder, and this H2SO4 is mixed in the BOD bottle. Then these precipitate will dissolve. We'll shake it well so that the precipitate which are settled down at the bottom will dissolve properly. Now see, the clear solution appears. Now from this clear solution, we'll take 10 ml of solution. Now 10 ml of solution is taken in the conical flask, and 2 drops of indicator. Here we are adding the starch. So blue color appears. This blue color is because of iodo-starch complex, as the reaction is iodometrically. So now this conical flask, the solution is titrated with the hypo solution. We'll add the solution slowly so that the reaction takes place. Now as the blue color disappears, then the end point appears. Reaction is completed. After getting the end point, we'll measure the reading. It is 0.4. Now we'll note down this reading, 0.4 reading, in the observation table, and we'll repeatedly do this experiment till the concordant reading appears. The concordant reading is the continuation reading, that is the same reading appears in the observation table. Through this reading we have to measure, we have to calculate the answer, that is the achieved outcomes, that what dissolved oxygen, how much amount of dissolved oxygen is present in the water sample.
Now after experiment, we got the following observations. We have to draw the observation table. In the first column, the serial number, then volume of water sample taken in ml. In third column, burette reading, volume of hyposolution, the initial reading of the burette, that is 00, and burette reading, volume of hyposolution, that is the final reading. And the last column is concordant reading. Now, first observation is 0.4, that is the burette reading is 0.4 ml. In second observation, again we get 0.4 ml, and in the third observation 0.4 ml. So our concordant reading is 0.4 ml. We have to do the calculation with 0.4 ml. If we do the titration very carefully, then we'll get the exact reading or correct reading. So this is 0.4 is our concordant reading. So we'll do the calculation with 0.4 ml. Now the calculation. Formula used for the calculation is N1V1 equals to N2V2. N1V1 of water sample and N2V2 of hyposolution. Now this is the normal equation, N1V1 equals to N2V2, it is the normal equation. Now our formula is DO, that is dissolved oxygen, is equal to ml of titrant into normality of hyposolution into 8 into 1000 upon V1 into V1 star minus V upon V1 star. Now what is this V1 star V? So here V1 star is volume of BOD bottle in ml, that is 300 ml of solution, 300 ml tap water we have taken in the BOD bottle. V1 is volume of contents titrated, that is 10 ml. V is volume of manganese sulfate and iodide azide we have taken in the BOD bottle, and V2 is ml of titrant, that is volume of hyposolution used. Now we do the calculation. We have already done the titration. So observations, that is the 0.4 ml we have to put in the formula. 0.4 into normality is 1 by 40, n by 40 is 1 by 40. So 1 by 40 into 8 into 1000 upon 10 into 300 minus 2 upon 300. So after calculating, we get 8.05 milligram per liter. This is dissolved oxygen present in the water. So dissolved oxygen in water sample is 8.05 milligram per liter. This is achieved outcome. Now our expected outcome is the amount of dissolved oxygen comes out to be 8.45 milligram per liter. This is the expected outcome, and our achieved outcome, what we achieved is 8.05 milligram per liter. So the gap between the expected outcome and achieved outcome is 0.40 milligram per liter. So we have done the experiment very accurately, almost accurately, because there is very minimum error. Now what precautions we have to take during the experiment? First, after the addition of reagents in the water sample taken inside the BOD bottle, the bubble check should be done and its removal should be done if formed. Second number, special care should be taken in sampling. And the last one is, as far as possible, the sample should not come in contact with air. So this is all about the experiment. Thank you.